This will be part 2 of graphing sine and cosine functions. So if you haven't watched part 1 where we discuss all the major components, make sure you do that. So here in part 2 we're actually going to put that to use and start graphing some transformations. So I will be referencing this sheet often. All of my students have this, and we'll be going through these steps. So before we begin, let's go through the steps here. I'll notice there are 2 step 4s. Need to fix that. Alright, step 1, identify the period, amplitude, step, and starting theta values. We'll do that in just a moment. Step 2, identify the changes to the x, which generally is theta. We use a variable of theta when we graph, and y coordinates compared to the parent function. So very similar process to all functions that we've worked with all year. Step 3, fill out your table making the changes identified in step 2. Establish a common denominator, this is important, between the step and starting theta value to make filling out the table easier. And make a table of at least 5 points, that's 5 step increments, to make sure you graph at least one period of the function. Step 4, make the scale of the x-axis, which is the theta axis, the same as your step. That makes it a lot easier to graph. And I don't care if you change the scale on any graph that I give you to make that easier. That's fine. And then what should be step 5, plot the points and connect them to sketch the graph. Alright, so let's look at this first example. And this would be the first one on Trig Graphing Practice 1 for my students. So let's do step 1 here. Let's go back to it. Identify the period, amplitude, step, and starting theta values. Alright, so the period is defined as 2 pi over b. So the b value is the multiplier in front of your theta. Well, between your, you could say between your either sine or cosine and your theta value. So you notice that's an implied 1 there. So it's 2 pi over 1, so it's just 2 pi. So the period is 2 pi here, same as the parent function. Okay, next, amplitude. The amplitude is the multiplier in front. So here is our amplitude. We'll abbreviate it as amp. So the amplitude is a 3. So that's going to be the height from the midpoint to the max and the midpoint to the minimum. Alright, and looking at our list here, identify the step and then the starting theta. So the step is the period divided by 4. So for us, that would be 2 pi, that's the period, divided by 4. Reduce that and you get pi over 2. So the step is going to be pi over 2 here. Alright, and then the starting theta value. So here is what we use for starting theta. So I'm just going to write start here. The start is going to be equal to 0 in this case. It's always 0 where you start unless you have a horizontal transformation. So if you had an addition or subtraction inside of parentheses with theta, that would shift your start from 0. So if it's right pi over 2, your start instead of being 0 would be at pi over 2. If it's left pi over 2, instead of starting at 0, your start value would be negative pi over 2. And we'll see some of those examples later. Alright, back to our list. So step 2, identify the changes to theta and y coordinates compared to the parent function. Alright, so we just have a change in our amplitude, and that is it. That is the only change here. That's this 3 multiplier right here. That's it. And step 3, fill out your table. Alright, so I'm going to go ahead and do the parent table, cosine theta, and then we'll do 3 cosine theta next to it. It's important that you start by seeing the changes, and I recommend you do this. When you get more experience, you won't have to always graph or make the table of the parent. You can just start making your table of the transform function. Alright, so in this column we'll put our theta value, and here we'll put our, you could say cosine theta, y value, f of x value. Technically it would be f of theta here. And then we'll do the same thing here. Here's our theta, and here's our function values, f of theta. So the parent function, you've got to have this memorized. It's just going, think of it as going 1 revolution around the unit circle. If we start at 0, then pi over 2, then pi, then 3 pi over 2, then 2 pi. And then our function values, it's the x coordinate on the unit circle for cosine theta. So it starts at 1, then 0, then -1, then 0, then positive 1. So there are the originals. Now, all that's happening here, your amplitude, instead of being 1, it's going to be multiplied by 3. So the theta values are staying the same. There's no horizontal shift at all. So we're going to rewrite all those. No change there. And then 2 pi. And notice this is your step right here. Your step is pi over 2. We're increasing by pi over 2, increase by pi over 2, increase by pi over 2, increase by pi over 2. So that's what that part is. And then now, instead of an amplitude of 1, we're going to have an amplitude of 3. So all that is doing is making everywhere we have a 1, we're making it 3. Everywhere we have a negative 1, we're making it negative 3, and so on. So the maximum is 3, the minimum is negative 3. It's 3 times what it was before. It was 1 and negative 1, now it's 3 and negative 3. So, and if you notice, just like any other function we've worked with, when you have a multiplier in the very front, it does multiply the y values. It's an effect on the y values only, which is what we have here. So I'm going to put in some dashed lines here for our max. Of course, these are just lines to help us graph. They're not actually part of the graph. And then we'll start plotting our points. So we have 0, 3 right here. Then we have pi over 2, 0 right here. Then we have pi negative 3 down here. 3 pi over 2, we're back at the middle. At 2 pi, we're back at the max. And then notice every 2 grid spots. So this is like 4 pi over 2, then 5 pi over 2, then 6 pi over 2. Same thing as 3 pi. And we can graph that thing in here now. So the only change compared to the parent function was the amplitude was changed from 1 to 3. So the height from the max to the middle is now 3, and from the middle to the minimum is now 3. That's the only change there. All right, let's look at another example. All right, for my students, this is problem 3 on your trig graphing practice 1. So cosine 2 theta. First thing we need to do is identify the period, the amplitude, the step, and the starting theta value. So the period is going to change here because we have a b value that's different. This is our b value. It's the multiplier that's between cosine and theta. It's right in front of theta. That is the b value from our part 1. That's how we label that as the b value there. So it's the period is always 2 pi divided by the b value. So for us that's 2. So 2 pi divided by 2 reduces to just pi. So the period now is pi. The period changed from the parent function. The normal period is 2 pi. So the step has to change too. The period changed, so the step changes. Normally the step is pi over 2. So we take the period, pi, we divide it by 4. That's how we get the step. So period of pi divided by 4 means the step is pi over 4. Then we need the amplitude. The amplitude is going to be easy here because it's not changing. There's an implied 1 multiplier in front, so the amplitude, just like the parent function, is still 1. So the max height is 1. The minimum is going to be negative 1 for this. Next, the starting theta value. So start. There is no horizontal movement here. There's nothing inside parentheses with this theta. No horizontal left and right movement. So the start will just be 0. Now we have step 3 on our chart. Fill out your table, making the changes identified in step 2. Make sure to establish a common denominator between the step and starting theta value. When your starting theta value is 0, you don't have to worry about that. Okay, make sure that you understand that. When your starting theta is 0, like normal, don't worry about making the common denominator. It doesn't matter. All right, so let's make the original table, cosine theta, and I'm just going to use y this time. So that's theta starts at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for cosine, it's the x value on the unit circle, so it's 1, 0, negative 1, 0, and positive 1. Now let's make the table for our transformed graph, cosine 2 theta. So theta and y. So the effect here is going to be on the x values. Notice this multiplier is in front of the theta there. So all that's going to change here is we're going to step up by pi over 4. Instead of stepping up by pi over 2, we're going to step up by pi over 4. Our y's are not changing. There are no changes to the y's over here, so I'm going to go ahead and fill those in. 1, 0, negative 1, 0, 1. Now, our starting value is 0, so we'll put 0 right here. Starting value is 0. Now, the step is pi over 4, so it's going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. I recommend you write it this way, and then you can reduce it later. I'm having to write small here. So let's go back in and we'll reduce these. 2 pi over 4, same thing as pi over 2. 3 pi over 4 doesn't reduce. 4 pi over 4, same thing as pi. Alright, so it is good here that each one of these vertical lines is actually pi over 4. Notice that if we start here at 0 and this is pi, there are 1, 2, 3, 4 total sections. So each one of those happens to be pi over 4. We don't have to change our scale here. So I'll put in the vertical max here at 1, vertical min at negative 1 here, and then we'll start plotting the points. So we're using this table over here, we have 0, 1 right here, then we have pi over 4, 0, so pi over 4 is right there. We're in the middle, then the min, then the middle, then the max, then the middle, then the min, middle, max, and we'd be back to the middle. So, and we'd actually be in the middle here. So our step, each time we hit either a max, a middle, or a min, is pi over 4. So we have basically horizontally compressed this graph. The period is shorter, so we go peak to peak and faster. So that shortens the period, that shortens the amount of theta travel to complete a full cycle. So this would be considered a horizontal compression. So there is our finished graph. Alright, I'm going to stop this video here, and in what will be part 3, I'll work the problem that you see here, cosine of the quantity theta plus pi over 6, so that's going to be a horizontal move. And then I'll also work this one, 1 plus sine theta. This is a vertical move. And then here we have an amplitude change and a period, and therefore a step change as well. And what will be this problem here, which is number 9, the way I have it labeled. So this problem, and this problem in the next video, which will be part 3.